Hi there, Year 11. Welcome to your next geography lesson. Hope you're all well. Do now tasks. You've got a 3-minute speed challenge here. What are the differences between a constructive and destructive wave? Write a list, just a series of bullet points. Keep it as simple as you can. And then if you have time, draw a diagram for each wave. Keep them simple, keep them quick. You've got 3 minutes. That's 1.5 minutes per wave. Good luck. Your time starts now. Pause the video. Okay, so here are some key characteristics of the two different types of waves. Destructive waves are plunging waves. They have weak swash and a strong backwash. They erode the beach. There's a high wave frequency for them. There's a lot of them. If you timed for a minute, there'll be more waves. They often form a steep beach. And there we go. Whereas a constructive wave has a stronger swash than backwash. It's entirely the opposite. A lower wave frequency. It deposits rather than erodes, and is a lower, flatter wave rather than the tall, plunging, destructive waves. Okay, so we mentioned their constructive waves and their ability to deposit. Well, that's what today is all about, depositional landforms. You've looked in previous lessons at erosional landforms, or you've looked at longshore drift and transportation and how that occurs, and today is we're on to depositional landforms. So read through the objectives, write the title and the date, and pause the video now. Okay, start with this video here. Just type that link in. There's also a couple of pages of the textbook attached. Do some information gathering, watch that video, flick through those 2 pages, have a little look through. There's some tasks using that information in a minute as well, so you'll get a chance to go back through in some detail and look for specific information. But this is your 10-minute time to get prepared and get as much knowledge into your head at this point as you can. So pause this video, watch that video, and have a read through those 2 pages. Okay, so we're going to start with our first subtitle, beaches. If you could write that and underline it as a subtitle, please. And then there are 3 full sentence answers to write. What can beaches be made from? Beaches can be made from, and produce a list. Which type of wave is responsible for their formation? The type of wave responsible for their formation is, and answer it. The process responsible for the formation. Well, that's a little bit more detailed. That's going to be a paragraph of an answer. A sequence of information, but fairly short and fairly simple for beaches. This should take you about 5 minutes. You've already read the information, so hopefully you can go straight back to it in the textbook. Use that. 5 minutes time. Pause the video. Okay, so check through these answers. Beaches, sand or shingle. Most beaches, in southern England are made from shingle because these have higher energy coastlines, which removes the finer sands. The shingle is left behind and the sand is taken away by the waves. So there we go. Number 2, constructive waves. They have powerful swash, remember, weak backwash. They construct, they build beaches. And number 3, low energy waves have resulted in deposition. Once sand is deposited, it dries out and then can be blown on shore. It's really simple for beaches. There are more complex technical ways of looking at it. If you'd like to look into one of those, you can have a look up and do a bit of research into wave refraction. That comes up as far as the consequences of headlands and bays, and it's one of the reasons why there is so little energy in a bay. It's not just the wave types, it's also to do with the physical layout of headlands and bays. So wave refraction, if you'd like to know more on that. Okay, we move on to spits. So copy that subtitle. Keep your notes nice and neat. You've got a definition to write out there, and another video. This video is great. I couldn't do it any better myself. It is an instructional video. It's got a diagram that they're going to draw, and once he's finished, actually, when we get to the next slide, you're going to be doing a copy of said diagram, but then writing up an explanation of the formation of spits using a series of numbered annotations to that diagram. So make sure you pay attention, go back, re-listen to anything you're not sure on. If there's still further questions, you know what to do. Email me, more than happy to help. Okay, so here's the diagram that the video ended with. If you could make a nice, neat copy of that, you can use colors if you want. You don't have to, as long as it's clear and nice and neatly labeled. You're going to be adding some numbers to this in a minute and then doing some writing following it. So pause this now, copy this diagram down. Okay, so add these numbers 1, 2, 3, 4, 5, and 6. You're going to write a series of numbered bullet points to explain or describe and explain what's going on. So tell me what's going on and why. Try to link them together though. Try to almost imagine that this is one paragraph you're writing. There's no numbers. Make it clear that one point kind of leads into the next. For example, this thing's just happened. Well, the next point, this means that. It just shows a bit of connective writing there. So pause now, add the numbers on, and write a sentence or two, a short paragraph for each number based on what you can remember. And if you need to, go back to the video, re-watch bits to check that you understand it. Pause the video now. Okay, so here's answers. Here's my versions. Obviously, yours are not necessarily going to be word perfect to mine, but as long as you've got the right idea, you need to read these and you need to check yours. And if you've missed anything out, if you think there's something that you've done incorrectly, you need to correct that now. So number 1, the prevailing wind blows at a coastline at an angle. So the waves approach the coast at an angle too. We're beginning our sequence right at the very beginning. In fact, right at the beginning of the longshore drift explanation. Number 2, this causes longshore drift to occur and sediment to be transported along the coastline. Now, I could go into more detail here about the ins and outs of longshore drift, the swash and the backwash. I took brevity as the approach here of being as concise as possible and as quick as possible. But if you want to make it more detailed, if you've done that, well done, good job. You could absolutely do that there. Number 3, this sediment reaches a change in direction of the coastline at a headland or a river mouth. Really important, really important. Without that, you're not going to find a spit for me. Number 4, the water here is sheltered and lacks energy, so deposition occurs and a spit begins to form. So I'm talking about the process here, the main key process now of deposition, but I'm also explaining why it happens. Number 5, as the spit grows, secondary winds may cause a bend or a hook to form at the end, pointing towards the land. And finally, as the water behind the spit is sheltered, a salt marsh may develop as plants start to grow in the shallow, salty water. I'd say number 5 and 6 are optional. If you haven't written those, you can add them on now, but they're certainly not integral to the formation of a spit. The spit is formed in number 4. However, nothing wrong with a little bit of extra detail just to really ensure that, should this be an exam question and an examiner is absolutely confident that you know what you're talking about, you're kind of showing off at that point. So, like I said, pause this video now, make sure you've got those points down. Anything you haven't, add them on now, and we'll move on. Okay, so on to the next landform. This is a nice and easy one, really bars. So copy the subtitle bars, copy that paragraph, and I'd like you to just quickly jot down that diagram on the left. It should be nice and simple. It's essentially a spit, but a spit where there's a change in direction of the coastline, and fairly promptly there's another one. There's another headland, say. So the spit can actually go all the way across, cutting off this lagoon behind it. Obviously, this is needing a lot of circumstances to be appropriate. It needs that sort of small old bay to be there. It needs to all be appropriate. If there was a river flowing here, this wouldn't form. Why? Well, because the flow of the river, water leaving the old bay, it means that deposition isn't going to occur, and obviously the river is not just going to keep flowing water into a lagoon and it building up and up and up. Eventually it would break through the bar anyway. So not on a river mouth, but on an old bay like it shows in the diagram. Absolutely, this could form. You don't see that many of them though, and actually some of them that you see aren't even caused by this particular process. There are other things going on, so quite rare. But there we go, a bar or a bar beach. If you could, like I said, copy the subtitle, copy the sentence and the diagram, a quick pencil sketch of that diagram, and that's it, job done. Pause the video now. Okay, our final landform and our final slide. Could you write the subtitle sand dunes? And you've got a number of tasks to do. You've got some information written on the screen here. You've got a diagram. The diagram is one that you're going to, again, in pencil, make a nice, neat copy of. However, you need to leave enough room for each of those labels, embryo dune, fore dune, yellow dune, etc., that you're going to add a little bit of information. A few more kind of, think like a spider diagram, a little bit of extra information on each one. There's a YouTube link at the bottom right there that I'd like you to watch as well. So absorb all this information, read through, watch the video, get all of this into your head, email any questions you've got over to your teacher. When you've done that, copy the diagram and annotate each key term with how it is formed. So for example, embryo dune formed around deposited obstacles such as pieces of driftwood or rocks. That's the information you're going to put attached to that, all on your diagram, linking it together there. Just to clarify on the diagram, the water table, well, as you can see, that's the sort of essentially anything below the water table is saturated ground. So you can see that that lies here exactly at sea level. So that is part of why the dune slack fills with water and becomes a pond. So anyway, there we go. These are the tasks for you to do. Once you're done, I'm pretty sure that's the hour up now. So that is lesson complete. You've got 4 depositional landforms. There we go. Yeah, cool. Have a lovely day. Take care. And I shall speak to you soon. Bye.